Okay, the next special parallelogram that I want to talk about is a rectangle. Most people are very comfortable with that one. This traditionally is what it looks like. I'm going to throw this Venn diagram in front of you again. A rectangle is a subset of parallelograms. So again, if you know something's a rectangle, all rectangles are parallelograms. So if you know something's a rectangle, you do have these 5 properties that are true. But in addition, you're going to have 2 more. So the first one here is our definition, and this says that if it's a rectangle, all 4 angles are congruent. So the rhombus had equal sides, and a rectangle has equal angles. Now, I'm going to talk later about the fact that quadrilaterals, the interior angle sum is 360. So if you divide that by 4, that means that a rectangle, more specifically, is going to have not only 4 equal angles, but they are going to be 4 90-degree angles. Okay? And then there is another property about the diagonals. So a rectangle, if you draw the 2 diagonals, they are going to be always congruent. The lengths of the 2 diagonals are congruent. So this diagonal will have the same length as this diagonal. It's a little challenging to show that in the picture, so I'm going to show it this way. Remember that for all parallelograms, the diagonals bisect each other. So that's still true, right? So if this diagonal is cut in half, and then that whole diagonal has the same length as that diagonal, that means all the little pieces are the same. So these 2 will have the same measure. So if you break all those little pieces down, they're all congruent. Unlike just all regular parallelograms, if I don't know that it's a rectangle, but I only know it's a parallelogram, it doesn't necessarily mean that that length and that length are the same as those, right? Okay, but if it's a rectangle, then yes, all 4 of those little pieces are going to be the same. Okay, so let's look at, again on page 3, I've got a rectangle that we can look at for problem solving. So they tell me that quadrilateral WXYZ is a rectangle, WXYZ, so that's a rectangle. If the length, so hopefully my brain is saying, okay, I got a parallelogram, so I've got all these that I can use, and then it's a rectangle, so I can also use these. So let's see what else they tell me. If the length of segment XO is 5, so from X to O here, that length is 5. What is the length of WY? So they want me to find WY. Okay, so since all parallelograms diagonals are bisected, this one is going to be the same as this one, right? Since that green one's bisecting the white one, or the one I didn't color, those 2 are both 5. Now, I know that diagonals for all for all rectangles are the same. So, what's the length of this whole diagonal? 5 and 5, 10. So what's the length of the green one there, of WY? If diagonals are congruent, the same, 10. Okay?